In this tutorial, you will create a 2-story wood frame structure with a 1-story garage from an imported CAD file. In addition to designing it for automatically generated wind and seismic loads, this tutorial will explain how to manually input loads and revise a design that was unacceptable. In general, it is good practice to define the initial settings and preferences followed by the site-dependent information. The user can go back at any point to change the settings or site information if anything changes. Following, there are 4 main steps to designing a structure in Shearwalls. These steps are defining the building geometry, the number of levels and their elevation, followed by drawing the walls, defining the details of each wall, openings, and the roof geometry using the form views, applying wind and seismic loads, either generated automatically or entered manually. Note that the loads can be modified or regenerated at any time. And finally, to run the design to determine the unknown values in the design, as well as to calculate the forces and capacities in order to verify if the design is adequate. Now to start, we will define the initial settings and preferences for the project by going in the Settings menu. In the Settings window, you can insert the company information, as well as project description. For this example, in the View tab, set the snap increment to 100 millimeters and make sure that the Fit View Area to Window and Fit Building to View Area are unchecked. Set the viewing area to the following, and set the display grid lines to off. As to the settings that will be used in the analysis, we will use the default settings. More specifically, make sure that the wind load generation procedure is set to NBC figure I-15. The reason that we are using this figure is that within the software there is a limitation to the low-rise figure. Shearwalls cannot generate wind loads using the low-rise structure when having multiple roof blocks. To know more about this setting, please refer to Tutorial 3, Design Settings. Make sure that the deflection analysis and worst-case rigid versus flexible options are activated. Furthermore, ensure that the shear wall rigidity per unit length is set such that the shear wall's deflection to calculate rigidity and distribute forces to wall segments based on rigidity options are selected. For a detailed look at the settings in Shearwalls for the Canadian version, please look at the video called Design Settings. Although this step could potentially be done just prior to generating the loads, we will define the site information now. The site information is available by selecting the Site Information icon. It is here that all the site-specific information related to the generation of loads is entered. For this example, we will use an importance category of normal. The menu is separated by 2 sections, Wind and Seismic Load Generation. In the Wind Load Generation section, the importance factor arising from the importance category is shown above the velocity pressure. For our example, we will assume a velocity pressure of 0.44 kPa, along with a second-order closed openings and a gust factor of 2 for the internal pressure. Note that depending on the percentage of openings versus full wall segments, that the software will notify the user of a more appropriate enclosure factor. The reference velocity pressure suggested default values can be changed in the Settings menu, and then choosing default values. We will keep the default values. Now back to the site information. It is here in the software that the information of the terrain, whether rough or open, is entered, as well as the information about any hills. The seismic load generation section allows the user to either use the calculated period based on the code or enter periods manually calculated by the user. Note that if the fundamental period enter exceeds the maximum allowed by the code, a warning will be issued when exiting the site information. Shearwalls also allows the user to enter the force modification factors, site class, and spectral acceleration values. Again, similarly to the velocity pressure coefficient for the wind load generation, the suggested default spectral acceleration values can be changed in the settings. We are now going to import a CAD file by clicking on the Import CAD button. Set the number of levels to 2, and afterwards click on Import File. In your Shearwalls directory, there is a file called Example. Select this file and press Open. We will import the same CAD file for both floors, but please remember that it is possible to import different meta files for each levels. Shearwalls allows up to 6 different CAD drawing imports. In order for your file to be compatible with Shearwalls, it should have a white or light background with black or dark lines for the drawing and text. We will now position the floors for the first level by clicking the Start Positioning and then selecting the bottom left corner and insert the desired coordinates for this point. Next, select the bottom right corner and specify a distance of 6.1 meters. Then select Finish Level 1. Repeat the same step for the second level. We now have a layout as a background, so we can design our structure accordingly. Select the Structure button and lay out the first block. In the field called Block Name, type in Main. Set the number of levels to 2. Now we will create the second block, which must overlap with the first block, and call it Garage. Set the number of levels to 1, and foundation elevation to 1.5. Note that the foundation and elevation also change for the main block. Now we will insert the walls. Upon exiting the structure action, walls are placed automatically around the edges of the intersecting blocks. It will not be possible to move, resize, or reposition the blocks while in walls action, but the blocks will automatically resize to follow movement of the exterior walls. Select wall 4-1 and separate it into 3 different segments by drawing an intermediate segment. Next, hold down Shift and select wall 4-2 to extend it. In order to limit the unknowns, we will choose the following properties for all the exterior walls with hold downs. We can now draw interior shear walls, which may or may not be required depending upon the magnitude of the loads. It is important to note that the software can only manage different shear wall material along a shear line if the option remains unchecked in the settings. This feature will be furthermore discussed in Tutorial 3, Design Settings. For this example, we will simply use the exterior walls as shear walls. It is also important to note that by default the program does not account for the weight of non-shear walls in the seismic weight, and that if it needs to be accounted for, it should be added manually or accounted through the floor dead load. Typically, all interior walls would be drawn and designed as interior non-shear walls, but for this example only a few interior non-shear walls will be drawn. Furthermore, only walls within the building footprint can be added. Next, select the Openings button and create a garage door by selecting wall 4-1 and clicking and dragging across the wall. Using the opening input form view, make sure that your offset from the edge is 1 meter, that the width is 4.1 meter, offset from bottom 0, and height 2.1. Continue to place door and windows opening around the structure as desired. Once satisfied with the openings on the first level, click on the Extend Walls button. This automatically creates the upper level walls for the blocks with multiple levels. This also recreates the openings on the upper level, therefore some openings might require some adjusting. To ease viewing, click on the Import CAD Drawing button and the layout will disappear. You can turn it back on at any point during the design by clicking on the CAD button. By extending the walls upwards, the upper level walls change to exterior with anchorages. To view the current openings, click on the wall E1 and click the Elevation View button. Whereas on the lower level we have exterior walls with hold-downs, on the upper floor the type of wall changed to exterior with anchorages. We will leave the edge spacing as unknown in the design and specify a 9.5 mm thick sheathing. To add a roof to both blocks, click on the Roof Blocks button, and roof blocks will automatically be assigned to each structure block. Select the main block, set the ridge direction to north-south, the east and west slopes to 30 degrees, and the overhangs to 0.6 meter. Select the garage block, set the ridge direction to north-south, and the east-west slope to 30 degrees, while setting the overhangs to 0.6 meters. Again, note that figure I-15 in the design settings is used in the wind load generation because we have two separate roof blocks and shear walls cannot deal with multiple roof blocks when implementing the low-rise figure. Note that once the Extend Walls or Roof Blocks button have been pressed, that it is no longer possible to modify the number of levels for each block. However, the story height may be changed at any time. The next step is to generate the loads, and at this point it is possible to modify the site-specific information by selecting the site information icon. Compared to earlier, a period for the structure has now been calculated. If a manually calculated period larger than what the code allows, the same warning will be displayed and the software will apply the maximum period specified by the code. We will now return to the default calculated code period. We will now select the Generate Load icon. Select wind and seismic loads to be generated from levels 1 to 2. Make sure that the snow load is included in the seismic load generation, and that the option to generate wall dead load for the calculation of GHG is selected. Click on Generate Loads on selected levels. This warning is to let the user know that this figure is typically used for flat roof, medium rise structures. We will proceed with the analysis as we have a multi-roof block structure and CP coefficients will be calculated based on the geometry of the blocks. The wind loads are now displayed in the plan view. You can view seismic loads by going to Show and clicking on Seismic. You can also view Level 1 seismic and wind loads by going to the first level. Now switching to the wind loads. If it is desired to view all loads acting on one wall, it is possible to do so by selecting the Loads and Forces icon and then selecting a wall of interest. Let's select wall A1. All the generated loads can be seen in the load input form. These loads can be modified or deleted at this stage based on your judgment. One can also filter the loads to see only type of load, for example, seismic. Loads can also be manually added. Click on the button Add, select Seismic Line Load applied to selected walls, and enter a magnitude of 3 kilonewtons per meter. Then select OK. Let's say we want to add a wind uplift load to wall line 1. Therefore, click on Add, choose Wind Uplift, apply to wall line 1 and a magnitude of 2 kilonewtons per meter. And then OK. To view the uplift load in the input form, it is required to reactivate the wind uplift option in the Show menu. And now the wind uplift load is shown. To view the load in the elevation view, select wall 1-1 and then click on the elevation view button. The loads for flexible diaphragm seismic design are currently shown. To view the wind forces, go to Show, Wind, West to East or East to West, and now it is possible to see the wind uplift force. In the event that this load was mistakenly entered, it can be modified or deleted by filtering the loads in order to find the entry more easily. You have to go back to the loads and forces, select wall 1-1, then remove the seismic load. Now only the uplift load is shown. Now we can delete it. We are now ready to run the design. Click on the Design button to run the program. The warning lets us know that there are some failure in the structure. The design summary table will allow us to see quickly where the failures are. The design summary is available by Go to Table and Design Summary. This section shows us a summary of the results for each portion of the design. For example, shear walls and hold down design for both wind and seismic. Here, it is possible to see that wall B3 is under capacity, as well as several walls are under capacity for components and cladding wind loads. Furthermore, several walls were found under capacity for the hold down design. These results are shown in details in the individual tables. For example, select Go to Table, Wind Design, Flexible Diaphragm Design, and Shear Results. By scrolling through the table, we can see that wall B3 has a critical ratio response greater than 1. Shearwalls also issues a warning below the table. Furthermore, by returning to the Loads and Forces view, it can be seen that shear line B is highlighted in red, indicating that the wall is under capacity. To view the wall in the Elevation view, click on wall B3 and then the Elevation view button. In addition to seeing the word failed, the shear forces, hold down forces, and drag strut forces are shown. By going to Show, Forces, Hold downs, and Separate, you can view the hold down forces broken up by its component. It is important to note that if both levels are shown in the elevation view at the same time, that even though the wall has failed, it will not be shown. Return to the Loads and Forces view and select Show Forces Rigid, and this will show you the rigid analysis force distribution. To learn more about rigid and flexible diaphragms, please view the tutorial for flexible and rigid diaphragm distribution. Now, in order to remediate to this situation, the properties of the walls will be changed by going back to the Walls view. Since the Design and Group option is selected for the exterior walls, applying the change to one wall will apply it to the rest of the exterior shear walls. We will increase the sheathing thickness and reduce the nail spacing for both edge and field, for both the top and bottom levels. Since the hold downs at some location failed, we will choose an appropriate hold down and rerun the design. Contrary to the walls, the hold downs need to be changed on an individual basis or by selecting all walls. It is not affected by the Design and Group. Based on the new Shearwalls properties, the program will run a new design. As it can be seen, there is no failure in the walls nor the hold downs. The remainder of the results, which includes the project information, structural data, loads, and wind and seismic design, is available using the Go to Table data bar. This concludes the second tutorial.